here. All right. Good. Awesome. All right. So yesterday you watched 3 short little clips that gave you an intro to vectors. The main things I want to bring out here is that vectors have a direction, they have a magnitude. So you can see this little arrow. Okay, the way that arrow is pointing matters. Okay, so you see a vector as you draw a vector, that arrow direction matters. It has all vectors are, when we write vectors, notice we're breaking it up to a horizontal and a vertical. We're essentially drawing a right triangle from this. It's got a horizontal, it's got a vertical. So some of our right triangle tree is going to come into play. That's why we're talking about vectors right now in the midst of our first semester when we just deal with trigonometry. All right. The horizontal component we put first when we list the vector. The vertical component we put second. Okay, it's kind of like you're doing slope, but we're not putting it as a fraction. Y'all remember slope, rise over run? We're just not putting it as a fraction. We're putting it inside of angle brackets, horizontal, vertical. Okay, it's still alphabetic like we've been talking about ever since we started talking about trigonometry. Okay, horizontal, vertical, A, B. Okay, and so you walked through yesterday in the video. How do I describe a vector? If I see a vector, can I have vectors that are exactly the same even though they're not in the same spot? All right, as long as we're describing a set of instructions. Doesn't matter where that vector is located, it's the same vector to us. Okay, so I went through some examples in the notes yesterday on that. And some of the problems we worked yesterday had you find a vector from 2 locations. I gave you 2 locations, an initial point and a starting point. You go from the initial point to the initial point to the terminal point. Give me the instructions. That's all the vector is. Okay. Again, when we write these angle brackets, this is going to be important today. The angle brackets are called component form because all we're doing is listing the horizontal and vertical components. When we use those angle brackets, not parentheses, angle brackets tell us the instructions that the vector is following. Okay? So if I have a positive horizontal, that means I'm going to go to the right. If I have a negative horizontal, I got to go to the left. I've got to denote which direction I'm going by a positive or negative. Okay, and again, in order to make sure we're doing this right, we have to have the correct starting point, and that's our initial point, wherever that is. That's our starting point, initial. Terminal points where we ended. Okay, so I went through some examples on that. You had some practice at getting those vectors. We also talked about magnitude. It should be open. Just have to push it. Magnitude. Magnitude, I think it was the 3rd video you have to watch. Magnitude is just Pythagorean theorem. So the important thing to note on that is you see those double bars. Some textbooks or some mathematicians will just put a single bars like it's an absolute value. Either way, when you see a vector inside of double bars or inside of single bars, it doesn't matter. It's a magnitude. It's the length of the vector. So for us, that needs to translate into Pythagorean theorem every single time. Okay? You have a horizontal part, you have a vertical part. You would just use the Pythagorean theorem. A squared plus B squared equals C squared, so you're going to have to take the square root. Okay? And so I went through some of that. Some of the things that I want to highlight here is that I saw in some of the ones that I looked over from your submissions yesterday, you need to try to simplify a radical, meaning if you have something like square root of let's just say you have something like square root of I'll use one that was in the assignment, square root of 50. Okay. I put in the assignment that I could accept square root of 50, but it's SQRT 50, no spaces. So if you end up getting it wrong because of that, you need to come back and let me know so I can give you some credit back. Okay, if I haven't already. But But something like this, we need to try to simplify. Remember I said at the beginning here, we are radicals. We're going to simplify. You're never going to see square root of 50 as an answer choice on an SAT, an ACT, or even one of our DCAs. If it can be simplified, we simplify it by breaking it down, looking for pairs. So something like this, what pairs can I use that make 50? 5 times 10, okay? The 5 is a prime number, so it's done. But 10? 2 and 5? Okay, so once I get all down to prime numbers, I look for pairs. So square root of 50, I can break down. I got a pair of 5s. I write the 5 outside. So really, what I need to have in Canvas is 5 SQRT2. No spaces, all jammed together like that. Okay. So you need to be able to do magnitude. Again, double bars means magnitude. All right. And then finally, that middle section in the notes from yesterday was about combining vectors. This is what we're going to do more of today. Because what I'm going to show you is going to actually hopefully make it less confusing to do. But again, you combine vectors simply by combining their components. That's it. You take horizontal part combined with horizontal part, vertical part combined with vertical part, and you do it in the order that they tell you with the operation they tell you to use. Okay. So that's kind of a quick overview of what you should have already done up to this point. Some of you will you didn't have any problems doing this, but I did see some people that weren't quite on point with that. All right. So hopefully what I show you today will make this a little bit easier to keep track of what parts get combined together. So whatever it is you're taking notes on, have that out because I'm going to show you something else that we need to know about vectors. We can write vectors with the angle brackets, and that's called a component form, or we can write them in terms of how many unit vectors, 1 unit vectors we use. So we get to define 2 1-unit vectors. We have a horizontal unit vector, meaning go just 1 unit to the right. How many of these little 1-unit vectors we can put together? And then we call that vector I. And then vector J is a vertical unit vector, meaning it's a 1-unit vector that just goes 1 unit up. So this is the main idea. I'm just going to do a short little lesson right here about using these unit vectors because essentially it's the same content as what you should have looked at and taken notes on yesterday. It's just a different way of writing a vector. One way of us writing a vector is with component form. Again, we use the angle brackets. There's no i's and j's in that. Okay, we just use the angle brackets. That's called component form. Since we're defining I as a little 1-unit horizontal vector and J is a 1-unit vertical vector, then I can take this component form and write it as what we call a linear combination. Now it looks more like an expression or an equation that we use algebra on. So now it would be turning into, I have this many of these I vectors, right? Because the A is the horizontal component. If I have I defining vector I as a 1-unit horizontal vector, then this horizontal component, I can say I have that many of those I vectors plus the B being the vertical component, I have that many of those little vertical vectors. And so I can write this as an algebraic expression. And what writing it as an algebraic expression helps us with is doing all that combining of vectors where now all of a sudden there's distributing involved and combining the horizontal with horizontal, vertical with vertical. It keeps all that stuff straight so you don't have to remember which parts combine. Okay, I'll show you an example here in just a second. But the main idea is that we have 2 ways of writing a vector. We can write it in component form with angle brackets and no i's and j's, Or we can take that component form and write it as a linear combination. Everybody say linear combination. Let's try again, linear combination. It's important you know the difference because there's going to be questions where the question says, write in component form. And I've got the answer choices set, so, or the answers that Canvas is going to accept. You got to have angle brackets with no i's and j's. If the question says write it in component form, that means angle brackets with no i's and j's. Then you're going to have a question that says linear combination form. Linear combination is use i's and j's, no angle brackets. Okay, you don't mix the two. So pay attention to what the different forms are. Okay. So let's go through a couple examples and then I'm done and you guys can work on the assignment for the day. You can ask whatever questions you guys, if you got questions from yesterday, you can do that. If you got questions from stuff today, you can do that too. Okay. So this number 4 says write vector u, which is 5 comma negative 8 in terms of I and j. Vector I is a horizontal, vector j is a vertical. So real quick, if my vector is in component form, let's see, it's 5 negative 8. What's that going to be if I want to turn that into linear combination form? 5i, right? Because that's the horizontal part. So 5i, let me put the little vector symbol over it, plus, or actually minus 8j. That's it. It's all it takes to go from component to linear combination. Because I is horizontal vectors and j is vertical vectors. This says I need 5 horizontal. Now, if the horizontal part is 5, what does that mean? 5 which way? Left or right? To the right, because it's positive. So it doesn't matter where I start, right? Because vectors are just instructions. This means go 5 to the right. 1, 2, 3, 4, 5 to the right. So I have 5 of these little 1-unit vectors. Okay, and then what does the negative 8 part of that vector mean? Go down 8. It's the vertical part. Okay, so in order to go down 8, I need to use these 0, 1s, but 0, 1 means go up 1. But I need them to go downward, so I make it negative. I need a negative of these 8 vectors here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's where the vector is going to end. Remember, vectors are just instructions, so I need 8 of these guys. So the vector looks like this, and again, the arrow is important. It tells me which way it went. Okay, a vector is just a set of instructions. It's not locations. It's not coordinates. We can take coordinates and figure out the vector for that, but that's what this vector would look like. And so that would tell me my set of instructions. I can write it as a component or I can write it as the linear combination. All right. So real quick, what's vector v as a linear combination? Negative 1i or just negative I, right? Because that would be like negative 1. And then the 3, is it positive or negative? Then I got to put plus 3j. Okay, that's the only thing new about what I need to show you today. Okay, now, what that helps with, just about done here, what that helps with is combining vectors. Okay, what that helps with, having i's and j's, helps us combine vectors because now all of a sudden we don't need to remember which ones go together. The ones we get to combine are the ones that have the same variable or the same I or the same j. Just like we do with algebraic expressions, we combine like terms. And so that's the benefit. Now, if you're asking yourself, what's the point? Well, what's the point of having I and j? Why not? Well, I can tell you this. When you get into electronic engineering, electronic engineers use I's and J's to talk about how that electricity is passing through the system. When we start looking at what things are interfering, when we start talking about interference, right? Since electrical waves and radio waves are waves, like sine and cosine, then we start to see, okay, which ones are interfering, and so some of them may be going this way, and some of them may be going this way. Well, that's like having an I and a J. And that's when these things get used, okay? So here, if it says U is 3I plus 2J and V is negative I plus 6J, write 2U plus 5E in terms of I and J. In other words, write it as a linear combination, okay? Again, this is where having I and J are helpful, because this says take 2 of this vector U. The vector U is 3I plus 2J. And then this wants 5 of these vector V's. And vector V is negative I plus 6J. Now it's just an algebra problem where you just simplify and combine like terms. I don't have to remember which ones go together. How would I simplify this? Distribute. This becomes 6I plus 4J. And this one, I'm going to distribute here. Actually, it's not going to be a minus. It's going to be, so that there is going to be negative 5I plus 30J. Okay, so I combine my like terms, combine my i's. What am I going to get if I take 6I and minus 5I? 1I, or just I. Okay, and then I'm going to take positive 4 and positive 30. I don't have to think about which ones get to go together because they have the same variable. I know they go together. So now that's going to be plus 34J. Again, this would be a linear combination form. How would I write that in component form? Angle brackets. What's the horizontal component? The number has the I, right? So if I just have an I, what number can I say is there? 1. Okay. What's the vertical component? 34. Then I close it off with angle brackets. Okay. Again, having I's and J's, the benefit of it is keeping track of which ones go together. All right. And that's the point there. Does it make sense? Yes? No? We good? Okay, let's take a look at today's assignment. If you haven't done yesterday's, you're behind. You caught up. Okay. Since these are going to go in next 6 weeks, if you get it in late, I can't technically count it late until after Monday. Does that make sense to you guys? You got some time to get yourself caught up. If you didn't do yesterday's, get it done. Okay. If you guys need me to do anything from yesterday, ask. If you want me to do anything from today's, ask. I'll do as many as you want. Okay. But again, for 12 weeks now, I've done problems here in class with you, and it still boggles my mind how some people can sit in class or sit in a Teams meeting and not even type in answers that I've given you on the board. I don't understand that. Question?
I was just going to ask number 1.
Number 1 on today's? Okay. Give me help on that one. What does that look like?
Can we read the whole problem?
Yeah, read the whole problem.
Let V be a vector with initial point -3, 1, and terminal point 4, 5, determine the following.
Okay, so this is vector V, right? Again, this is the initial. This is the terminal. Okay, we want to find vector V. We want to find the component form, right? Because I'm giving you 3 things to do, right? Component form, linear combination form, and then magnitude, right? Okay, so if I want to do the component form, okay, again, since I give you coordinates, you need to tell me the instructions that get you from this coordinate to this coordinate. Initial to terminal. Okay, so what are my horizontal instructions? How do I get from a -3 to a +4 as an x coordinate? What's the instructions you got to tell me to take?
-3 - 4.
If I go from -3 to a +4, that's 7 units, right? And 7 units which way? To the right. I got to go from initial to terminal, so I'm going to have to do a +7 to get from this x to this x. Again, a vector is just instructions. You tell me the instructions. Here's my starting point. Here's my ending point. Give me the instructions to get from here to here. Okay, so that's a +7. That means in component form, I got an angle bracket and then a 7. Okay. Well, what are the instructions I got to take for the y's?
1 to 5.
Okay, so from a 1y value to a 5y value, what's my instructions? Which way do I got to go? 4. So then that means my vertical component is a +4. So comma, 4, angle bracket. Again, when you put these in, after a comma, put a space. Okay? After the comma, put a space. Now, how do I write that as a linear combination? You need to have it as a 7i plus something or 7i minus something. So what is it?
7i plus 4j.
7i plus 4j.
So you just put like the letter?
That's it. Now you didn't have a plus and minus in between.
No spaces.
No spaces, no commas, no angle brackets, nothing. So again, you either have angle brackets and a comma, or you have i's and j's with no angle brackets and commas, but you need to have a plus or minus in between there. No spaces. This one, space between the comma and the 4. Okay, this one, no spaces anywhere. Best way to have it in there. I've got it to accept some different things, but I'm not going to sit here for 20 minutes putting every different combinations of people could use. They could put spaces anywhere they want. Okay, so again, to get it right, comma, space, no commas, no angle brackets. All right, and then we got to do magnitude. How do we do magnitude? Well, what does this vector mean? I started someplace, and I went 7 to the right, and 4 up. That's my vector. Magnitude is how long is that vector? Pythagorean theorem. That's all magnitude ever means. Okay, so if I'm going to do the Pythagorean theorem, magnitude of vector v is 7 squared plus 4 squared. Let's do that. What's 7 squared? 49. What's 4 squared? 16. 49 plus 16. 65. Okay, can we break up 65? 5 goes into it for sure, right? Because it ends in a 5. 5 should go into it. So what's 65 divided by 5? 13?
Yeah.
Am I going to get any pairs from that? No. Then my magnitude is just square root 65. No spaces.
65?
Square root 65.
So the magnitude is basically the hypotenuse of it?
Always.
Okay.
Yep. Again, so that's what the component form is. That's linear combination. And then magnitude is just Pythagorean theorem. You take your horizontal plus your vertical, horizontal squared plus vertical squared, and you take square root of that. Okay, that's it. All right, I'm going to stop the recording now, so that's enough for anybody that missed.
Sure, if you get an answer from magnitude, like let's say 65 is the answer, you would just put 65.